For this week, we're going to be looking at two different chapters, so chapter 7 and chapter 9. So we'll start with 7, and some of this stuff is, more detailed than maybe we want to do in this class, but we do want to at least mention some of these concepts. So start with the idea of what factors influence climate, and I think that was on our last test, the difference between climate and weather. You can see I still have the definitions over on the right-hand side. And so we really didn't talk about what kind of determined climate. It's solar energy, the angle of the sun, the Earth's rotation, water and air circulation, actually the gases in the atmosphere and how thick they are on parts of the planet. Things like mountains and all those different things will determine the climate of a particular area. And so here are the Earth's climate zones, and we're, if you look here carefully, we're in the warm temperature area. We're considered to be a Mediterranean climate. What I do want you to know for our area, obviously, is we have wind patterns and ocean patterns. So it is actually the California current that is typically kind of driving our coastal temperatures. It's a cooler current coming up from the north, coming down here into Southern California. And so all of this has a big impact. And then messing with these also has a big impact. So as we go on, air circulation patterns and ocean currents, what I want you to know, these are moving around heat and precipitation unevenly. So depending on where you live and how things are happening will affect on how the climate in your area is. So again, uneven solar heating of the Earth's surface, and it depends on the time of year, depending on the angle of the Earth facing the sun. The rotation of the Earth itself actually causes ocean currents, the Coriolis effect, and then the properties of air, water, and land. It's cooler near oceans and lakes. That's a property of water. So all of these things add up to what we consider climate. So here are the global air circulations, and I want you to know these. You can see these little cells on the right-hand side, and you can see there are 6 of them. And we're going to talk about these just a little bit, but these little gyres are really what set up weather patterns. And what people don't understand is they are all interconnected. And so what you can see here, right here in the middle, warm air rises and moves toward the poles. This here is setting up for the next one, which is setting up for the next one. And actually by chopping down our tropical rainforests and deciduous forests, that is actually causing these global air circulations to change a bit. And we are afraid that that is going to cause major global changes in climate, which then will lead to less biodiversity because organisms may not be able to adapt quickly enough to this changing issue. So let's just talk about our local. So we'll hit on this. Prevailing winds and the Coriolis effect drive our ocean currents here. And again, we typically have most of the time the California current coming down from the north, but we do get what's called El Nino, and you might have heard of this, and they call it also the Southern Oscillation, where there's slight changes. So when there are winds in the tropical Pacific Ocean that weaken and change direction, we can get some large-scale effects, and it typically warms our local waters, and we see major changes. So we've had El Ninos and El Ninas, maybe a milder case, but they happen quite a bit. And so again, organisms have adapted to these changes, but we'll see, at the tide pools that I take classes to, we'll see changes over the years. You get different species, or you start seeing fewer or more of a certain species because of weather patterns. You'll see that with the sharks. We'll have more gray whites because the warming water will bring in certain types of fish, which bring in the sharks. So all of these things, again, if they're on a kind of cyclic scale, and they're fairly mild. You know, animals can adapt and deal with. But if we have major changes, that could be an issue. The other thing I want to talk about here, I decided, was the rain shadow effect. And because of the way our geography here in Southern California is, we have north and south running mountain ranges. And so we have most of our air comes from the ocean, and it blows inland. Although, you know, we have things like Santa Ana is a bit different. But what happens is the water in the air, the moisture in the air, that gets dragged in. When it hits a mountain, that interrupts the flow. And so what happens is the clouds and things actually start to rise. And as they rise, it gets cooler. And it turns out warm air holds more moisture than cold air. So as those clouds rise, what will happen is it'll start dropping water on this side of the mountain range. As it gets up and over the mountain range, it starts to drop. It starts warming the air again, which holds more moisture. So very little rain will drop on the other side. And so that's why we have the deserts located where they are here in Southern California. They're on the other side of the mountain range. As a matter of fact, much of their rain is later, and it's actually tropical storms that blow up from Texas and the Gulf of Mexico and places like that. So a little bit different. But anyway, so that's called the rain shadow effect. So I want you to be aware of that. And that we will stop this recording.